This module is looking at generating the DC link, which is the process that occurs when changing the truck from rest to ready mode. Shown here is the system circuit overview. Before we start, let's take a look at a few components. The voltage attenuation module, also called the VAM module, monitors the voltage via VAM3 on the output of the main rectifier. VAM3 also monitors the three-phase voltage coming into the main rectifier from the main alternator. VAM4 looks at the AC tertiary winding output, which is the supply to the AFSE, and also the field voltage being applied to the alternator rotor slip rings, which is the output of the AFSE. The main alternator is mounted directly to the engine and provides a single-phase supply to the AFSE and a three-phase supply to the main rectifier. It consists of stator windings and rotor poles. The generator field contactor is a DC contactor that connects the output of the AFSE to the rotor circuit within the main alternator. The AFSE, shown here, is a full-wave controlled bridge rectifier and contains multiple components including the battery boost card and two gate firing modules. The R1 battery boost resistor limits the battery boost current to 40 amps to protect the wiring in case of a short or ground in the rotor circuit. Without the resistor, in the event of a fault, there could be uncontrolled current causing damage to the circuit. Finally, the GFR relay connects battery power to the field circuit via the R1 resistor. Now let's take a look at the circuit in action. The SCR3CM circuit, what we refer to as the battery boost card handbrake circuit, has a continuous connection of approximately 20 volts. The resistor, commonly known as a pull-up resistor, will ensure that the SCR3CM circuit is held at a voltage. So, if there is approximately 20 volts applied to SCR3CM, the battery boost card is effectively disabled or locked off. There will be approximately 20 volts at SCR3CM, almost exclusively except for when you are transitioning from rest to ready. Now, let's look at generating the DC link via the system, going from rest to ready. The first step is to start the truck and have the engine running. Next, let's now operate the rest ready switch, which is a switch on the dash within the operator's cab. This will cause the GF contactor to close and connect the output of the AFSE to the main alternator rotor that is attached to the engine crankshaft and as such is rotating at engine speed inside the main alternator. The system will then close GFR, which connects the truck batteries to the alternator field circuit via the R1 resistor. The system will also switch a 24-volt signal onto the wire AFSEL via a high side driver from the 17FB104 card in slot 5. The AFSEL is used to enable the battery boost card, although nothing will happen due to the SCR3CM circuit holding the battery boost card disabled. It will also enable both the gate firing modules on the AFSE. The system is now set up ready for operation, but there is no excitation as SCR3CM is still holding the battery boost card in the disabled state. The next step is to release the handbrake by taking the SCR3CM circuit low. The function is performed by a low side driver on the 17FB104 card in slot 5 of the card rack that will pull the circuit low, effectively enabling the battery boost card, i.e., removing the handbrake. Once SCR3CM is taken low, the battery boost card will trigger SCR3, and this will cause current to flow from the truck 24-volt batteries through GFR through the R1 resistor to the positive terminal on the AFSE through the main alternator rotor that is rotating around inside the main alternator, back through the GF contactor through SCR3 and back to ground. We are now in battery boost mode and have approximately 40 amps of current flowing in the alternator rotor circuit. With the rotor spinning at engine speed and now passing current, this means that there will be some excitation within the alternator. Voltage will appear at the tertiary winding output and we will also have three-phase voltage feeding the main rectifier. There will be approximately 250 volts on the DC link. Tertiary voltage levels will be fed back to the control system via VAM4. When the system recognizes a voltage at the tertiary, it will commence firing the gate firing modules that control SCR1 and SCR2 within the AFSE. This will cause the AFSE to start drawing some current from the tertiary that will cause the output of the main alternator to increase. So, firing pulses to the gate firing modules 1 and 2 on the AFSE, which in turn control the respective SCRs. These pulses are timed respective to the AC waveform coming from the tertiary. As the tertiary produces an AC voltage, there will be an alternating positive and negative at output terminals of the tertiary winding. At a point in time with one terminal positive and one terminal negative, current will flow from the positive tertiary connection down through SCR1, through the rotor field inside the main alternator, in the same direction as the battery boost current, back through diode 2, and back to the supply. Now we have additional current flowing through the rotor inside the main alternator. There will be additional excitation in this circuit, and the voltage at the main rectifier output will increase to 300 volts. At a 300 volt output, the alternator is effectively self-excited and battery boost current is no longer required. At this point, the system will disable the battery boost card by allowing SCR3CM to return to a voltage, effectively reapplying the handbrake. This in turn will remove the gate signal from SCR3 and battery boost current will cease to flow. The system will also increase the firing to the gate firing modules, which in turn will draw more current from the tertiary winding and deliver more current to the alternator field. More current through the alternator field will create greater excitation from the main alternator stator, and the increased excitation will cause the DC link voltage to rise to 700 volts once the system has completed VI testing. For further information on training and other services we offer, please reach out to the Ostindo team on 02 6574 9700 or via our website www.ostindo.net.au.